Hi, and welcome to the Intrepid Sea, Air, and Space Museum's live public programming Journey to Space. My name is Kara, and I'm an educator here at the Intrepid Sea, Air, and Space Museum located in New York City. Just as a reminder, the museum's live programs are free, but if you'd like to join us in delivering this amazing content, please click on the link located in the chat or the comments. So speaking of the chat, feel free to tell us where you're tuning in from, if you've ever been to the Intrepid Museum, and feel free to answer any questions or participate throughout the program. Again, my name is Kara, and I'm an educator at the Intrepid Sea, Air, and Space Museum, where our mission is to honor our heroes, educate the public, and inspire the youth. So let's get started. So just to kind of give you some background information of where I am coming in from, this is the Intrepid Museum today. It's huge. If you were to get off at Times Square and go west, we are located right on the Hudson River between New York and New Jersey. Now, just a couple of fun facts about the museum. The ship itself is about 913 feet long. It's about as long as 3 football fields. So if you put those football fields next to each other on the flight deck, you could play 3 games of football at the exact same time. If you were to measure it from the top to the lowest deck, it's about 8 stories tall. So if you're walking down that West Side Highway, you can't miss us. We are massive. But what makes our museum really interesting is that we are housed inside of a World War II aircraft carrier, the USS Intrepid. Now, the Intrepid began its construction in 1943, right before the U.S. was sent into World War II after the bombing of Pearl Harbor. The Intrepid served from 1943 to 1971. It participated in World War II, the Vietnam, and the Cold War, and did some work for NASA, which we'll talk about in just a little bit. And then became the Intrepid Sea, Air, and Space Museum in 1982. So it's pretty obvious on why we're called a sea museum, right? We have things like this on board, right? We have a lot of airplanes. And going back to that previous picture there, you can see a lot of those airplanes on board. Does anybody know what the name of a vessel is called that can carry aircrafts? Let me know in the chat. Now think back to World War II in 1943. It was really impractical and very difficult to get these airplanes from one continent to another. So they had to be carried there. The Intrepid had these airplanes that could take off and land on the back, just like a floating airport. So I see some of us in the chat said an aircraft carrier, and if that's what you were thinking, you are correct. Like I said, the Intrepid carried these airplanes. They could take off in the front and land on the back, just like an airport would, like a floating airport. Had that nice long runway on board. So I did mention that that's what makes us a sea museum, is that the Intrepid is floating out in the ocean. It's also an air museum because it carried airplanes, right? Today in our collection, we have a little over 24 airplanes on board that you can come and check out. Everything from the Avenger that served during World War II to jet planes like the Fury that served during the Vietnam War. So we've got a large collection of airplanes, right? And that's what makes us an air museum. Can anyone in the chat tell me why you think we might be a space museum if we're the Intrepid Sea, Air, and Space Museum? Let me know in the chat if you know why we might be called a space museum. We have air for our airplanes, we have sea because we're a ship, but why are we a space museum? Well, this, my friends, is the reason that we are a space museum. This artifact right here is why we're considered a space museum. Can anyone in the chat tell me what they think this is? Let me know if you've ever seen anything like this before. I'll give you a hint. It was used during the space race. So if you would have said a space capsule, you are correct. This is what helped the first astronauts get into outer space. This space capsule would sit on top of a rocket during the Mercury programs, either the Atlas or the Redstone rocket. They would ride that rocket up into outer space. It would separate, and the capsule would go on and complete its mission. Now, in the 1950s, there was something called the space race going on between the United States and the Soviet Union. Today, they are Russia. Now, you could say that the space race officially started on October 4th of 1957 when the Soviet Union launched Sputnik. It was the world's first artificial satellite, the first object to orbit around the Earth. Right? This made the U.S. very nervous, and thus the space race began. So I want everyone to think about the term space race. And we know that in a race, you have a finish line. So where do you think the finish line in outer space might be? Tell me in the chat if you know of a place that would be really great to land on that could potentially be a physical endpoint for the space race. Now, if you said the moon, you would have been correct. But getting to the moon is not easy, especially in the early days of space exploration. You can't just put these astronauts in a space capsule, throw them up into the sky and say, hope you make it. No, you've got to take these baby steps. You've got to test things out. And so NASA decided that if they were going to get to the moon, they were going to break this up into 3 different missions or 3 different projects, starting off with the Mercury missions and these astronauts right here. This is the Mercury 7. They are composed of these 7 astronauts. And today we're going to focus on this astronaut right here. This here is Scott Carpenter. And this capsule belonged to him, the Aurora 7. All of the capsules had a 7 at the end of their name because there were 7 astronauts. Right? So this Aurora rocket sat on the top of an Atlas, or I'm sorry, it was the Aurora capsule sat on top of the Atlas rocket. And in 1962, Scott Carpenter orbited the Earth 3 times and was up there for about 4 hours and 39 minutes. Right? Again, this is one of the first times we are going up into outer space as Americans. It's a huge deal. We can't go straight to the moon, so we're testing things out like orbiting, right? And like I said, he was only up there for about 5 hours. Now, this made him the 2nd American to orbit the Earth and the 4th American in space. Now, coming back down to Earth, can anybody tell me in the chat where you think it would be a good place to land? Maybe the Earth is covered in about 71% of it. It's softer than landing maybe on the hard ground. Tell me in the chat if you know of a space or an area that Scott Carpenter could land his capsule and it wouldn't get, easily damaged. It would keep him safe. So if you would have said in the ocean, you would have been correct. This is called a splashdown. Yeah, and I see Quentin in our chat telling us the ocean. Right? This is called a splashdown. So as those astronauts are coming back from outer space, they are coming in super fast. So they're going to let out these parachutes. They're going to create some drag, and they're going to slowly bring them back down to Earth and land on the ocean. Right? It's kind of hard to miss the ocean. So Scott Carpenter landed in the Atlantic Ocean, just northeast of Puerto Rico. But something very interesting happened. They were supposed to go pick him up, but when they got there, he was nowhere to be found, right? So what actually ended up happening was as Scott Carpenter was entering the atmosphere, he got a little bit distracted. And honestly, I can't blame him. If I'm coming in from outer space and I'm looking out a window, I would probably get distracted too, right? So he admitted that he started his landing preparations just 2 seconds too late, and he activated his retro rockets just a couple seconds too late, landing him about 250 miles off course in the ocean. So you can imagine that it was pretty hard to find him, right? So once he was found, thank goodness that there was a large vessel nearby that could deploy a helicopter and go pick up Scott Carpenter. Let me know in the chat if you know of a big, huge vessel that could carry aircrafts, send helicopters to pick up Scott Carpenter and his capsule. It's a place very near and dear to my heart. If you would have said the Intrepid, you would have been correct. So the Uss Intrepid helped NASA as a recovery vessel by picking up Scott Carpenter, right? Awesome. So this is a good place to stop and have a question break. Does anybody have any questions? Why was it called Project Mercury? So think about like I said, this was one of the early stages of space exploration in the space program. So if you think of the name Mercury, you've probably heard of the planet Mercury. Now, if you think of its place in the solar system, it's the #1 planet in the solar system. It also orbits the sun faster than any other planet. It goes around the sun in about 88 days. So it's the #1 planet, and it's the fastest. Just like the US wanted to be the #1 on the moon and the fastest one to get there. Awesome, good question. Any more questions? Did Scott Carpenter leave the capsule when he was in space? So he did not. Things like EVAs or extravehicular activities don't come until later on. His main mission and his main goal was to, like I said, to ride that rocket up, separate from the rocket, orbit the Earth 3 times. He stayed up there for about 5 hours before coming back down to Earth. So Scott Carpenter never left his space capsule. Good question. So, like I said, NASA broke up their missions on going to the moon into 3 different projects or missions, right? We first had the Mercury mission, which only took up 1 astronaut at a time before transitioning into the Gemini space program. And here you can see these 2 astronauts right here. This is Gus Grissom and John Young, and they rode up on their Titan II rocket. So after Project Mercury, with Project Gemini, we were able to do just a little bit more. We were able to take things a little bit further, like doing spacewalks or EVAs, right? And that's when you're actually able to leave your capsule. They were able to stay longer in outer space. Gemini 7 actually stayed in outer space for almost 2 weeks. That's insane to me. I can't imagine staying next to anybody for 2 weeks in a small capsule. Right? They were also doing things like tasting food and taking up more food. Now, Gemini 3, like I said, took up 2 astronauts named after the Gemini constellation of the twins or the 2 brothers. And like I said, Gemini 3 here had Gus Grissom and John Young. Now, I've mentioned a little bit about space food. And space food back in 1965 was not very appetizing. It was dehydrated, it was freeze-dried, and it was coated with oil or a gelatin to prevent it from crumbling. So water would be introduced, and they'd actually kind of have to squish it up and get it all rehydrated, and then they'd slurp it up. Just by looking at this picture here, that foil square is a chicken sandwich. You can see that there are cinnamon toasties. The tubes at the top are liquid orange juice. So space food at the time was really, really gross. Now, the day of his launch, while they're in orbit, John Young decides to pull out a corned beef sandwich that he had snuck into that he had smuggled into outer space in his spacesuit. Now, we know that in outer space, there's very, very little gravity, right? Microgravity. And when he started to eat this sandwich, something very interesting happened, right? Here on Earth, when we take a bite of our sandwich, those crumbs just fall straight down to our lap. But if we're in outer space, those crumbs are actually going to float. Now, you're probably thinking they're just crumbs. What's so horrible about crumbs? But if you think about it, those crumbs could have gotten lodged into the buttons. They could have gotten into the ventilation system. They even could have gotten into their eyes and ears. Remember, the astronaut safety was one of the most important parts of this, and just crumbs could have jeopardized the entire mission. So, of course, when they returned back to Earth, they got in, I was going to say a little bit of trouble, but a lot of trouble. And they had to personally apologize to Congress for possibly putting this whole mission in jeopardy. NASA warned future crews that nobody better ever pull this stunt again. They were definitely not happy. But by sneaking that sandwich up into outer space, we actually learned a lot. NASA knows that you can't take bread into outer space. Today, they use tortillas, right? And here's Peggy Woodston here, and she actually has a hamburger on her tortilla there. If you look a little closely, you can see it's got mustard, there's some cheese on it, there's onions. I don't know if that looks appetizing to you. It kind of does to me. But again, this is the reason we can't take bread. We have to make our sandwiches with tortillas, right? Now, astronauts also, when they're in outer space, they actually lean towards spicy food. And it's because food tastes different in outer space. Because of the lack of gravity, something called a fluid shift occurs. And basically, it leaves the astronauts' heads feeling like they've constantly got a cold. And if you've ever had a cold, you know that that kind of messes up your taste buds and your sense of smell. So a lot of the times, they like to eat spicy food. So going back to Gus Grissom and John Young, like I said, they rode up on their Titan II rocket. They went about 140 miles off the surface of the Earth, and they orbited the Earth 3 times before coming back in for a splashdown. Now, if you look here, again, you can see that we have those parachutes that are going to catch some air, create some drag so that these astronauts can kind of slow their descent back to Earth. You're going to have a splashdown in the ocean again. And when they land, you can see here that there's that green dye coming out of the space capsule, and that's so that we can easily see the astronauts. And so while they're waiting to be picked up, you can see they're hanging out there. And you can also notice that there is that yellow ring around the space capsule that's called a flotation collar. Now, again, with the early space missions, we were learning and creating a new way and new things for the next mission, right? Everything that we were learning previously, we were applying it. And Gus Grissom had actually been a astronaut on the during the Mercury missions on a Liberty Bell. But something very interesting happened when he came back from outer space. When he landed in the ocean, his hatch actually popped off, and his capsule started to fill up with water. Now, that water, of course, sank the capsule. Gus Grissom was able to get out, but it's the reason that we know that we need that flotation collar. Yeah, Shy Gamer says, oof, not a fun time, right? So that also led Gus Grissom to want to name his Gemini III capsule the Unsinkable Molly Brown after the Broadway musical, because he wanted it to be unsinkable, right? NASA, for some reason, didn't let anybody else name their capsules after this mission, unfortunately. So, of course, these astronauts are out in the ocean. They're waiting to get picked up. Again, can anybody think of a large vessel that might be nearby that could pick up these astronauts and their capsule? Big, beautiful thing near and dear to my heart? You probably guessed it. It was the Intrepid. USS Intrepid. Right, so here you can see a picture of the Intrepid picking up that capsule using their crane. If you visit the Intrepid today, you can actually see a replica of what that would have looked like picking up that capsule, right? And it was a really big deal to have astronauts on board. Awesome, so I'm going to stop here and see if we have any questions. Were any other capsule programs named after Greek mythology? So yes, NASA loves naming their capsules and their rockets after Greek mythology. Just thinking back to the Mercury and the Gemini missions, we had the Titan rocket, we had the Atlas rocket. Today we have the Pegasus rocket, Saturn rocket, right? They also, the projects were also named Project Mercury, Project Gemini. Later on, we have Apollo, which we'll get to in just a little bit. And then in the future, we have Artemis, who's Apollo's twin sister. And of course, the Orion, right? So we've got a lot. NASA really likes to name their capsules and their projects and their rockets after Greek and Roman mythology. To me, I like to think that they were the first owners of the sky. So it's kind of a nice homage to them. Awesome question. Any more questions? Do they eat better food in space now? So yes, again, like I said, astronauts tend to lean towards spicy food because you have that fluid shift going on. They bring up tortillas. As you saw, Peggy Winston had a hamburger, right? Unfortunately, there are no refrigerators on the ISS because the only fridge on board is used for biological experiments. So I don't think you'd want to have your sandwich next to a biological experiment, right? They also take up salt and pepper today, but it's also in liquid form. Again, you don't want salt and pepper particles kind of floating around, getting into your eyes or your ventilation systems as well. These meals are planned out by nutritionists, so everything is calculated for calories and making sure that the astronauts have enough vitamins and nutrients for their food. Right. Also, I believe it was back in January, the first time that cookies were ever baked in outer space happened. Unfortunately, those cookies took about 2 hours to bake when you're thinking about the gravity and the heat and everything that's different about ovens on Earth, right? Good question. So I did mention, right, we started off talking about getting to the moon, and that started with Project Mercury, doing our first tests. Can we even get up there? Can we orbit around the Earth? Doing Project Gemini, taking up more astronauts, doing more experiments, eating food, right? Then came the Apollo missions, right? 6 Apollo missions achieved the goal of going to the moon with the famous Apollo 11 crew landing on the moon on July 20th of 1969, right? Now, all the work of Mercury and Gemini without all the work of Mercury and Gemini, the Apollo missions would not have been possible. So as we continue, we are learning and applying everything we've learned to the future missions. So here's our famous Apollo 11 crew. Can anybody in the chat tell me this crew's name? Anybody in the chat know any of the names of these men here on the famous Apollo missions? So on the left here, you can see that we have Neil Armstrong, right? On the right, we have Buzz Aldrin, who famously walked on the moon. And in the middle there, you have Michael Collins. Now, unfortunately, Michael Collins never got to walk on the moon. His main job was to basically drive that getaway car. So while Neil and Buzz were walking on the surface of the moon, Michael Collins was actually orbiting around the moon waiting for them to be picked up. It was a really big deal, and it kind of seems to get forgotten every now and then because he didn't walk on the moon like the other two did. Now, unfortunately, Michael Collins passed away about 2 weeks ago at the age of 90. So, like I mentioned earlier, 6 missions going to the moon were able to bring back about 400 kilograms of lunar samples. They were able to do research and experiments on things like meteoroids, solar wind experiments, and so much more. So I mentioned earlier when we started talking about the space race and how the finish line was the moon, right? Now, the U.S. landing on the moon effectively won the space race, which began almost 10 years earlier with Sputnik. Whew. So now that we know a little bit about the history of NASA's space program and what it took to get to the moon, let's talk a little bit about what it's like to live in space. Tell me in the chat what you know about outer space. Maybe the kind of gravity it has, the air. What is living in outer space like? Tell me what you know about space. So here on Earth, right, and I'll make myself a little bigger here. Here on Earth, we have lovely things like gravity that keep us down to the ground. They hold us here and prevent us from floating away. Whereas in space, there's very little gravity or microgravity, right? And if you ever watch videos of the astronauts on the ISS, they're floating, their hair is kind of up and about, right? Here on Earth, we also have something very lovely called air that allows us to breathe. And when astronauts take spacewalks and EVAs, they actually have to wear a big suit to protect them from the vacuum of space. Here on Earth, we also are surrounded by a nice big bubble called our atmosphere, and that contains all the air that allows us to breathe. It's held in place by gravity, right? So within our atmosphere, all the air around us has weight and is exerted on everything around us, but we don't feel it because we're pretty used to it. So there's about 15 pounds of pressure per square inch on you and everything around you. To kind of put that into context, imagine a regular sized house cat, right? And that house cat's weight, so about 15 pounds, is on every square inch of your body and everything around you constantly under pressure, right? Again, we don't feel it because we're so used to it. So let me know in the chat, what do you think would happen if I took away all the air pressure, or if all the air pressure was removed, all the air? What do you think would happen? Maybe to our bodies, to everything around us. I see Cassie in the chat saying that's a big house cat. Yeah, 15 pounds is a big house cat. So I'm going to show us what it would be like if we were to take all of the pressure off, right? We're going to recreate the conditions of outer space and the effect that it would have if astronauts didn't wear their spacesuits, right? So what we have here is a bell jar, and it's connected to a pump. That pump, when turned on, is actually going to remove all the air from inside of this container. Now, I've placed water in this bell jar because water takes up about, our body is made up of about 60% of water. So as you can see, as that pump was turned on, it created that seal at the bottom inside of our chamber here. Now, notice what happens to our water inside when we take out all of that air. Now, just for context too, this is room temperature. You're going to have to take my word for it, but it is room temperature water inside. So you may have noticed that there are water bubbles forming, right? And if you look closer, that water is going to start to boil. Now, here on Earth, matter exists in solid, liquid, or gas form. Air pressure from the atmosphere keeps these molecules compressed in a liquid state. But if we remove that pressure, there's nothing holding on to those molecules and keeping them together. They're actually able to spread out and create water vapor. So imagine all of these molecules being compressed. That weight of the atmosphere is taken off and they're able to spread out, causing them to turn into water vapor and boil. Right? So now we're going to take a look at what might happen to, let's say, our lungs if we were put inside of a vacuum chamber and all of that air was taken out. So here we've got a red balloon with just a little bit of air, and we've got our blue balloon that doesn't have a lot of air. So let's imagine that we're in a space capsule or a spaceship in outer space, and somebody opens a window. So while you're running over to close that window, do you want to take in a big gulp of air, like our red balloon? Or do you want to let all the air out of your lungs, like our blue balloon? So you can see we've got a little bit of air in our red balloon. Tell me in the chat, what would you do? Would you take in a huge breath of air, or would you let out all the air in your lungs? Now, hopefully nobody opened a window in outer space, but let's imagine that somebody did. So we're going to put our bell jar cover back on. We're going to hook up our hose to our vacuum here, and we're going to start to take out that air from inside of our vacuum chamber here. So let me know in the chat, what would you do? Take in a big gulp of air or let it all out? So you might have noticed that our red balloon is starting to get really, really big, right? So just like our molecules in our water, same thing is happening to the air in this balloon, right? That all that pressure is being taken off, and those molecules are able to spread out and relax, causing this balloon to get a little bit bigger, where our blue one is taking a little bit longer, right? So anybody want to tell me now if they've taken a deep breath or let it all out? If this represents our lungs? So unfortunately, your lungs would eventually pop if you were in the vacuum of space. This part's always really fun, right? Awesome. So now that we know a little bit about what air pressure, removing that air pressure would do to your lungs, let's think about what it might do to your body, right? So we're going to put this marshmallow in here, and we know that marshmallows are basically made out of sugar, air, and water, right? So as we put it back in our bell jar, we're going to take a look at our marshmallow, and you can start to notice that automatically our marshmallow is getting a lot bigger. It's starting to expand, right? But something interesting is going to happen when we reintroduce that air into our marshmallow, right? Can anybody think about what might happen? Is it going to go back to normal size? Tell me in the chat what you think might happen to this marshmallow when we reintroduce air. So Shy Gamer says it's going to wrinkle. Well, let's see. So as we reintroduce air, it wrinkles or it shrinks right back, right? Because all those air pockets that it originally had are actually gone. Awesome. So now you can see why it's extremely important that astronauts have to wear spacesuits when they're out doing their EVAs, their extravehicular walks, right? They need to make sure that that whole spacesuit doesn't have the tiniest little rip or the tiniest of little holes, because something very dangerous could happen. Not a good time, right? So this is a good place to have a question break. Anybody has any questions? Any questions? Do astronauts have to wear the spacesuit in their capsules? So in their capsules, yes, they would go up and they would use their spacesuits in their capsules. Now, of course, you have to wear a spacesuit when you leave your capsule because, like I said, just the tiniest hole could actually take all that air out of your suit. Again, your blood and your saliva would start to boil. Your lungs would expand until they pop. Again, your skin would have kind of like the same effect as that marshmallow as well. So you wouldn't be having a good time, right? Now, of course, when astronauts are riding up on things like the space shuttles, they have to be wearing their spacesuits inside their space shuttle until they get to the ISS. Good question. Any more questions? Awesome. So we're going to go on, and we discussed earlier how all of this journey, right, and all these steps are what helped NASA eventually get to the moon, right? So after the moon landings, NASA decided that they wanted to focus on low Earth objects, right, in orbit, and they wanted to take up bigger things, right, and stay in outer space for longer periods of time. And we were able to do that with things like this. I'll make this a little bit bigger. This is our Space Shuttle Orbiter Enterprise, and you can see this on the flight deck at the Intrepid Museum. If you were on the flight deck and you walk all the way to the back, you can't miss it. It's in this huge shuttle pavilion. Now, back when we were talking about capsules, those were one-time uses, one and done. They landed in the ocean, we'd recover them, and they'd never be used again. But shuttles were really great that they could be recycled and used multiple times, right? Now, I hope this doesn't ruin your day, but if you come visit the Space Shuttle Enterprise at the Intrepid Museum, it never actually went into outer space. The highest it went was about 26,000 feet. Oops, not that. The highest it ever went was about 26,000 feet and went about 470 miles per hour. So not very fast and not very high. If you've ever been in an airplane before, you've probably gone higher than the Space Shuttle Enterprise, right? But you're probably wondering, how did we get from space shuttles like Enterprise to space shuttles like this that could go about 17,500 miles per hour and go about 350 miles off the surface of the Earth? Right? So Enterprise was built as a prototype. We needed to see if it could even work, right? Again, thinking about the Mercury and the Gemini space program, when we were trying to get to the moon, they didn't put astronauts in these capsules, send them up, and hope they make it. We had to take these baby steps. Same thing. Enterprise was the first one ever made. It was a prototype. It needed to test and make sure that it could do things that later shuttles could do. Now, like I mentioned earlier, those capsules in the beginning were one and done. Space shuttles were really great because they could be recycled, right? These shuttles are about 122 feet long, and they weigh about 150,000 pounds. So could you imagine this space shuttle landing in the ocean and having a recovery vessel like Intrepid pick it up? It's kind of extremely difficult when you think about it. So our shuttles were built so that they could take off like vertically, but that they could also land on a runway like an airplane. Now, because Enterprise was a tester, you can see here that back in 1977, it rode on the back of a 747 jet. We needed to make sure that we could get it up in the air and that it could glide back down to Earth and land on a runway just like an airplane could. And Enterprise proved that it could back in 1977 with its ALTs, or its approach and landing tests. So after testing of Enterprise, right, NASA made 5 more orbiters afterwards, did 133 successful launches, with the last one in 2011 with the Space Shuttle Atlantis. Now, when we acquired the Space Shuttle Enterprise at the Intrepid Museum in 2012, it was celebrated with a victory lap around New York City on the back of a 747 jet, just like it did back in 1977 on its first test. So again, if you were very disappointed that Enterprise never went up into outer space, you might be happy to find out that at the museum we have a Soyuz capsule. Now, just looking at this picture here, you can see that it's a little bit toasty from re-entry because this capsule actually went into outer space and came back. And if you're at the Intrepid Museum, you can find our Soyuz capsule underneath the Space Shuttle Enterprise in that same Space Shuttle Pavilion. Now, these Soyuz are Russian spacecrafts. And like I said, if you were disappointed to know Enterprise never went up, Soyuz definitely did. Now today, our astronauts get up into the ISS using Soyuz space capsules, and up until recently, it was the only way to get there until, of course, the introduction of SpaceX, which was the first crewed orbital space flight launched from the U.S. since the final shuttle missions. Now, these Soyuz capsules here can hold 3 astronauts, and from the looks of it, you can see that it looks pretty cozy, right? Got a lot of nice cushions surrounding them. Every seat on the Soyuz 2 is specifically fit to fit that astronaut's body. So if you were to lay in one of these seats, it would not be comfortable to you, right? So like I said, what's really interesting about these capsules here is that they don't land on the water like the Mercury or the Gemini missions did, right? These capsules actually land in the deserts of Kazakhstan on Russia's southern border, right? It still has that parachute to catch some drag or catch some air, create some drag to slow it back down when it's coming back down to Earth, but it also has some rockets underneath that help it slow down as well. Like I said, it's a very comfortable ride. Every seat is fit to fit that astronaut. So we're going to stop for a quick question break here if anybody has any questions. When the water boiled, it got colder from the evaporation and lower pressure, right? So the temperature didn't actually change when we were taking off the pressure. Like I said, it started off at room temperature, and the temperature didn't change at all. It stayed exactly at room temperature because all we were doing was taking off that air pressure. Those molecules were able to spread out, kind of have like a dance party, if you will, creating it to make it look like it was boiling. But all we did was take off the pressure. We didn't apply any heat. Good question. Any other questions? Where are the other space shuttles today? So there were 5 space shuttles after Space Shuttle Enterprise. You had Columbia, Challenger, Discovery, Atlantis, and Endeavour, right? And today you can find Enterprise, of course, in New York City at Space Shuttle or at the Intrepid Sea, Air, and Space Museum. You have Atlantis at the Kennedy Space Center. You have Discovery at the Stephen F. Udvar Hazy Center in Virginia. Endeavour in the California Space Center. And of course, Challenger and Columbia are not around anymore. You had Challenger that failed during launch and Columbia during re-entry. Good question. Awesome. So wrapping up our journey to space, right? Make this a little bit bigger here. NASA is currently working on the Artemis missions to get us back to the moon. Now, you're probably wondering, why are we going back to the moon if we've been there so many times, right? So earlier I did mention that Artemis is named after Apollo's twin sister because Artemis will be carrying the next man and the first woman to walk on the moon. But again, you're probably wondering, why are we going back to the moon? Well, eventually NASA wants to get to Mars. But again, just like we didn't go to the moon on our first launch, we have to make sure that we can get there, right? So NASA is going to start off by sending Artemis 1, and that's going to be an unmanned mission going to the moon. It's going to orbit around the moon and come back. NASA is going to send Artemis 2, which is going to take 4 astronauts. It's going to go orbit around the moon again before eventually taking the astronauts that are going to land on the moon. But again, Mars is in the future. So what does that look like, right? Well, because we're going to be venturing a little bit farther, we're going to need a lot more fuel. More fuel adds more weight adds more fuel. So this is going to be a very heavy mission that's going to require a lot of fuel, right? Now, again, the most efficient way to get there is going to be for Earth and Mars to be at particular locations in orbit. When launched, it's essentially going to transfer orbits, and that only happens every couple of months. So the timing has to be just right in order to be fuel efficient. Next, Landing on Mars. Mars's atmosphere is very thin. Here on Earth, we can deploy parachutes on rockets, but there's a higher risk of crash landing, right? Now, rovers on Mars are pretty light, so comparing sending humans with all their stuff to Mars is going to be an extra challenge. Now, that's just getting there, right? We have to consider actually landing and staying on Mars. The temperature, the gravity, the atmosphere are all very different. We have to bring livable habitats and support systems that are going to protect our humans on Mars. So just as early space missions, we're learning on how to get up into space, how to breathe in space, how to eat. Scientists are constantly still learning more and more every day about what it takes to get further into Mars. Eventually, with everything that we've learned in the past, we're going to journey further than we've ever been before. So thank you for joining me today. The museum has introduced a number of live programming that you can find on our website at intrepidmuseum.org or the link in the comments in the chat. Our next program is going to be next Tuesday, May 18th at 3 p.m. It's going to be Star Stories, where you can learn a little bit about how sailors navigated using the night sky and the constellation stories from different cultures. Hopefully you leave here looking at the night sky in a whole new way. Now, the museum is open to the public, so you can join us Thursdays through Sundays. We're open from 10 a.m. to 5 p.m., where you can come see Space Shuttle Enterprise and our Soyuz Capsule, along with over 24 of aircrafts in our collection, including a submarine as well. If you enjoyed this program, we invite you to answer a quick survey located in the chat or the comments. So once again, my name is Kara. Thank you for joining me today on Intrepid Adventures. See you next time.